Okay, so from this question, we can see basically how to calculate the empirical formula. Okay, from this data. And another question. Oh no. Okay. So here is about like combustion analysis. So combustion analysis is a very important way in analytical chemistry to determine the molecular. So it often used for organic compounds. So we know organic compounds, they contain like carbon, hydrogen, and some other elements like oxygen and nitrogen. So basically, these elements are in the organic compounds. So in combustion analysis, the organic compounds is burned in the presence of oxygen to basically form carbon dioxide and water, and also other gases. So we can, for example, if we get unknown organic compound, we can just burn them, and then we can get the mass of the products, like the mass of oxygen, the mass of dioxygen and the water, and also maybe other gases, and then determine its molecule. Okay, here is a question. For example, a sample of compound that is known to contain only carbon, hydrogen, and oxygen. So basically, most of organic compounds are only made by carbon, hydrogen, and oxygen. Most of, although of course some maybe include some nitrogen. Okay. And when it is combusted, so the carbon dioxide and the water produced are trapped and weight. So now we know the original sample weight 8.3 grain, and yet 16 grain of carbon dioxide and 9.5 gram of water. So what the empirical formula? How to get its empirical formula? So here are the molar mass of carbon dioxide and water. So here we know the total mass, right, of the compound, total mass, and we know when it is burned, like this mass or this gram of carbon dioxide. So from this information, what we can get?
That's a question.
We know the mass of carbon dioxide. So if we use this number divided by its molar mass, what we can get? Yes, number of carbon. Okay, and we also know the mass of water. So if this mass divided by its molar mass, what we can get? The moles of hydrogen. Yes, and then after we know the moles of oxygen, mole of carbon, and we also know the moles of hydrogen, so we can know the mass of the carbon and the hydrogen, right, in the compound. After we know the mass, the total mass of carbon and the hydrogen in the compound, we can now clear the total mass of the compound. So we can get the mass of oxygen, right? Just total mass minus the mass of carbon and hydrogen, and then we get the mass of oxygen, because the compound is only made by carbon, hydrogen, and oxygen, right? Okay. So here is the answer. So basically, we know the more we know the weight, the mass of carbon dioxide. So just using this number divided by the molar mass, and we can get the moles of carbon, right? And also from this mass, we can get the moles of hydrogen. Yeah, something. Let me see. Oh, here should be time 2, because this is mass. This is mass. This is mass of hydrogen or mass of water, and this is the mass, molar mass. So we get the molar mass of water, right? But in each water, how many hydrogen? 2, yes. So the moles of hydrogen. No, this is wrong, I think. I just used this is from other place. Okay, anyway. So here is like should be 2. Okay, now we know the mass. We can calculate the mass of carbon. The mass of carbon, just use mole times molar mass. This is the mass of carbon. And the mass of hydrogen, right? And again get this. So we can get the mass of oxygen in compound. This is the total mass minus the mass of the carbon minus of hydrogen, and then we get the mass of oxygen with oxygen. When we know the mass of oxygen, we can just divide it by the atomic mass of oxygen, right? And then we can get the mole number of oxygen. After we get these 3 numbers, we can get the empirical formula is this. So how to get this? How to from these numbers to get this? So it's like, say, from this ratio, we can get this ratio, right? So how to from this ratio to this ratio? How to do? Why we can from this ratio to get this? How to do? Or you should know the way how to from this ratio to this ratio, right? How to do? Basically, yeah.
You divide those numbers by the smallest numbers. So like 0.364 divided by 0.182.
Yes. 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 Basically, from these 3 numbers, right? So just using the smallest one. Which one is the smallest one? Of course, this one, right? So using this one as like so all these numbers divided by the smallest one. Okay? So this one divided by this is 2, this one is 6, and then of course it's 1. So after you get this, so you can write the empirical formula. Empirical formula is C2H6O1. So you need to remember how to from this ratio to this ratio. Just use the all the numbers divided by the smallest one. Okay? Okay. Now we know the empirical formula just tells you the simplest ratio of the individual elements in the compound. So for if it's in ionic compound, so this formula is also this is enough. This also is a chemical formula, right? Because the chemical formula of the ionic compound is also the empirical formula. But for like the covalent compound, so this may not be enough, since the empirical formula may not be the molecular formula. So we need to know its molar mass. We also need to know its molar mass. When we know its molar mass and also its empirical formula, then we can figure out its chemical formula. Okay. So this means besides the empirical formula, we also need to know its molar mass, and then we can get its chemical formula. Okay, now question. For example, this is a question. Elemental analysis of sugar. You know sugar, right? Okay. Shows that it consists of 40% carbon, 6.7% of hydrogen, and 53.3% of oxygen. And we also know its molar mass is like 180 grams per mole. Now we need a KMH. Now we need to figure out what is molecular, what is the chemical formula or molecular formula. How to do it? So basically, first step we need to figure out its empirical formula, right? And according to its empirical formula and the molar mass, we can get the molecular formula or like chemical formula. So how to get first step, get its empirical formula. So how to get its empirical formula? Yeah, we know that. So of course this is also the mass percent.
Yeah.
Anyone want to try? Yeah? Oh. We can clean this. It's like what or not? No? Can't? Ah, you should come here. You can do it, yeah? Oh, okay. Try. I don't know how to do.
Yes. This guy no.
Captain. We are together.
This connection, what's going on?
No, mine.
You go.
Yeah, we direct you. The girls are.
Hey, you can discuss. You can also discuss.
Yeah, we can discuss. Yeah. Mine.
You told me what to do.
We got you.
No, we're serious.
Let me help you to. You know, right?
No, I don't.
Yeah.
Did you take the picture first?
This one is in.
He's not using.
Has refused.
I know, you can just.
What?
Yeah.
Picture first.
Uh,
The floor.
But where's the you
Oh,
get
it will
the
come down.
slides? The slides come down.
You come back. How is she?
Where to find the
question.
Oh, the question.
the question?
Oh, the question is here.
Okay, good.
So smart. Never mind.
That's so smart.
No, I can't see on this.
Oh,
screen.
you can't see?
No.
Okay.
Just do the order.
Just write on the same
Okay,
thing.
exactly.
Funny.
You can write on the same thing. You can see.
Yes, I can. And yes, over this, I can see.
This and then
Wait,
the
40% of carbon.
So we have 40%
Of carbon.
percent of carbon,
56.
C,
6.7% of hydrogen.
6.7%
7%
of
of hydrogen.
hydrogen,
53.3.
53.3 of
Oxygen.
Oh, sorry.
And the molar mass of the compound found will be 180 grams per mole.
So the molar mass,
180
It's
one,
more
80.
atomic mass.
grams per mole.
Oh, okay.
What is the molecular formula?
Then you should add how to clean this stuff. Oh, nice. You are smart.
What's Monitor.
Monitor. Monitor must be smart, right?
Yeah.
so
Molecular formula. Define the molecular.
what do we do next? We said we're doing this together.
Oh, first finish. Atomic masses. For each.
Wait, what was the percentage of oxygen?
I don't know what I'm writing.
This one. Okay. Atomic masses. 12 for carbon. 12.01. For hydrogen, 1.01. And for oxygen, 16.
So we'll do calculations. The carbon just using 12, okay, and the hydrogen 1, and oxygen 16.
One.
Yeah, continue. Yeah.
And you've left me.
Oh,
Francis.
What do you say? Find the number of moles in each of them. So you divide each of them by their molecular mass. So for example,
So
carbon.
for carbon,
Yeah. Or the most number of carbon. How to get
the mass number is
how to
12.
get the
So it's 40 over 12.
Yeah,
40 over 12. Wait, what are we finding right now?
the number of moles.
The number of moles is in.
And
Yeah.
and okay.
You said 40?
over 12.
It's mass, okay. Divided by yes. Atomic mass. And then yeah,
The answer is
Yeah.
0.3.
therefore the answer. Okay, good. Now we get the moles of carbon and the hydrogen.
Hydrogen
Yes.
is 6.7.
So the same, 6.7.
Huh?
6.7.
Yeah.
The answer is 6.76.
Or divided by 1 6.
Yeah.
And then for oxygen, 53.3 divided by 16.
3.3.
It's also 3.3.
And then say yeah, after you get this more numbers, how to from this most numbers to get the empirical formula.
So how do we do it?
The smallest diameter.
The smallest is 3.33. So it's divided everything by 3.3.
So 3.3 divided by everything is what?
Divided by the smallest one. Yes.
1 to 1.
Yes.
1.
Yes. Okay. So what the empirical formula?
CH2.
Carbon is 1, right? Yeah.
CH2.
Yes. This is empirical.
Oh,
See?
You said carbon is 12, right?
CHO2.
CH2O.
Yes. Now you know the you figure out this empirical formula. So and then how to now you know the empirical formula. Also know is molar mass. molecular mass. So how to get the formula, molecular formula.
How do you get the molecular formula?
Molecular formula.
Oh, so
Yeah.
it's 12 plus 1 times 2 plus 16 into brackets n is equal to
Yeah,
one.
you should calculate is the mass of the empirical formula.
So the mass of carbon is 4, the mass of hydrogen
12,
is
yes.
110
plus
Plus
2
Yeah.
plus 16.
plus 16
Plus
plus
16.
What's
Oxygen. Oxygen thing. Okay.
Okay, my question is why?
why?
Why using this way to calculate the mass of empirical formula?
It's
Why?
like to show that hydrogen.
No, you should know why. You should know why.
Because the atomic mass of carbon is 12, then for hydrogen it's 1, but it has 2.
Yeah, two. Yes. Yeah, and oxygen. Yeah,
And
this is why.
oxygen.
This is
Yeah,
this is the
that-
mass
that's
of
why.
as empirical formula. Okay.
Let's go.
Okay. Lambo, what's the
The answer is
what's the answer?
30.
Everything in bracket is
yeah
Times 10?
n
Oh,
is equal to 1.
is equal to 180.
Equals to 180.
Yes.
Oh.
Yeah.
So,
Okay.
Then
So now you need to think out what the n.
yeah. I don't know why.
N is 6.
N is 6.
Yeah. 30. 180 divided by 30.
Yeah.
So basically, you then get this answer, right? The answer of this line, what is? So yes, that's right.
N equals to 6.
N is 6.
Yes.
And why is N 6?
Because
At the end
30 N equals to
Yeah, one
180.
example. You should firstly plus this number together. So what is this number? 12 to 16, and then
That's this.
13. Yes.
Yeah,
So
so
that's
so for
13.
n. So for n.
Okay,
Make n
this is
the number.
13, right? Okay. So 13 times n should be 120. 180.
Oh.
So n is 6. No,
Yeah.
I mean 6. Just want to rate it yourself, right?
Yeah. So
Yes. Now you know.
know.
Okay, good.
Yeah, N is what?
6.
Okay, now you know n is 6. What the
How was
molecular
the
formula? What the molecular formula? You should write out. You should write out is molecular formula.
C6H12.
So
Which one was that?
C, 6, H,
yeah,
or 6.
Why?
Oh, that combined.
Because
But
of
it
the,
has
of
both.
the,
Yes, because the n number is 6, so we have 6.
Outside.
So 2 times 6 12. Okay, yeah, good. Perfect.
thank you, thank you.
Yes, no, man.
Exam.
Oh, we should know where.
I hate it again.
Okay,
I don't know the name of it.
X. Will be hex. Yeah.
okay, here is also the answer.
Yeah.
Here's the answer.
In the exam.
So basically, we know the percent of the carbon, hydrogen, and the oxygen. So you can calculate they are most number, okay? And then when we know they are more number, we can get is the ratio of carbon, hydrogen, and oxygen is 1 to 1 to 1. So we can get is empirical formula. Okay?
Yes.
After we get the empirical formula, we can calculate the mass, so the molar mass of the empirical formula is 13. 13. So after we get the 30, I'm just using the molar mass of the compound minus divided by molar mass of the empirical formula. So we get 6. So 6 is means the molecular formula is like this. Okay? And also is this. Okay? No problem, right? Good. You know, maybe this question will be in your final text.
Yeah.
Maybe
It should come.
every questions in the slides will be maybe in the final text. So you should know how to figure out all questions in the slides. Okay?
She should know. I mean, he should know.
You know, I just tell you some very important thing. Okay, homework.
Homework already.
The homework for this semester.
So
No, for
this
this chapter.
So that's it, it's a class time.
Yeah, bro.
No, sorry, it's over.
So the class is over.
Class is over for today.
Okay, so
Class is over.
I was going to make a week.
how to figure out the
Yes. Quite yet.
What are you doing?
Six. Chapter 6. Okay, so just now we introduced the formation of compounds, right? So basically the compounds are formed by the chemical bonds formed. So in this chapter we will introduce some basic concepts about the chemical bonds. Okay, in this chapter we will learn the Lewis dot symbols, and we also introduce the polar covalent bond, and how to write the Lewis structures, and we also introduce the bond enthalpy and enthalpies and enthalpy changes in reactions. Okay, so we know for each atom there are two kinds of electrons, right?
Yeah.
One is the outside, the most outside electrons. Another is the inner electrons. And the most outside electrons, we call them like valence electrons. Okay, so the valence electrons are the out-shell electrons of an atom. And the valence electrons are the electrons that form chemical bonds. So basically, just for example, for two atoms, the shell electrons, definitely these electrons are from the valence, from the out shell electrons. So these electrons are also called valence electrons. So, for example, with a group, there are 1A, 2A, 3A like this. And we also know there are electron configuration. For example, 1A is an S1, 2A is an S2. So basically, so there are the number of their valence electrons for 1A only 1, and this guy has 2, and this one has 3. So for this, in this part, we just introduced the elements from, they are representative elements. You know, for all elements, they are like representative elements. There are also some other elements, it's called like transition metals. So for representative elements, there are valence electrons are filled in S and P groups, P orbitals, S and P orbitals. Okay, so we can figure out there are the numbers of there are valence electrons. Okay, yeah. So in this part, we just introduce how to write the Lewis structure about these atoms in these relative elements. So here we saw the number of valence electrons is 1. This has 2, right? And this has 3, 4, 5, 6, 7. Okay? So we can use this way to describe the elements. So this is also called Lewis dot symbols. Lewis dot symbols. So from here we can see that for 1A it has only one valence electron. So we just use 1 dot. Okay, 1 dot. And the 2A they have 2 valence electrons. We can use the 2 dots. 2 dots, okay. And this is 3, 4, 5, 6, 7. And of course this is 4 orbitals. 4 orbitals. So this way is called Lewis dot symbols. Lewis dot symbols. So we're using this way can determine the number and basic arrangement of bonds in compound. It means the number of the bonds. What this means? This means in a compound between 2 atoms, it may form 1 bond. It also may form 2 bonds. It also can be has 3 bonds. 3 bonds. So using this way, we can determine the numbers of the bonds in compounds. Okay, so we can recover this is about octet rule. So here we can see for no metals, basically they try to get electrons from metals. For metals, they basically tend to lose electron. Okay, here we can use this way to describe the process of the reaction. For example, in this reaction, the lithium has 1 valence electron, so it's 1 electron, right? And the fluorine, it has 7 electrons, 7 valence electrons. Okay. So in this case, this guy lose 1, give 1 electron to this guy. So the fluorine, it has 8 electrons, okay, and the lithium no valence electrons. So it has plus 1 charge. This is minus 1 charge. Okay. So we can use this is called Lewis structure. So this is about the reaction of the ionic compounds. So in ionic compounds, so the metal lose valence electrons, and this guy has A electrons. A electrons, the S and the P orbitals are full. Okay, so they are stable. Okay, now we introduce how to use the Lewis structure to show the formation of covalent bonds. The covalent bonds means the 2 or more electrons are shared by 2 atoms. So here, why should the 2 atoms share electrons? For example, in this case, for fluorine, they need one electron, right? They need one more electron.
Yes.
So when they share these two, so here we can see for this fluorine, it has A electrons. Yeah, and also in this, it also has A electrons. So we can use this is loose structure of fluorine, F2 gas. So here we can see they show two electrons. So two electrons forms one bond. So we can use this line, this short line, to show the bond. So this is also called a single covalent bond. So in this case, we can see between them, they share these two electrons. These two electrons forms the single covalent bond. We're just using this way. And of course, for each fluorine, it has other 6 electrons. So these 6 electrons don't join the covalent bond, right? So they called lone pairs. Okay, so in this structure, you can see there are some. For each one, it has 6 lone pairs and one single bond. Okay, so this is the formation of single covalent bond. After they form the single covalent bond, so each atom has A electrons. Okay, so this is the formation of single bond. We also can use this picture to show the formation of a single covalent bond, like 2 hydrogen, right? Each hydrogen has 1 electron. Okay, so they share these 2 electrons. So form a single hydrogen bond. And the 2 chlorine, of course, 2 chlorine, each chlorine has 7 valence electrons. 7 electrons. So when they share one from another one, so it has A electrons. And this guy also has A electrons. And they share 2 electrons, so they form the single covalent bond. Okay? Okay. And of course, we know the compounds has only 2 atoms, but sometimes it may have more than 2 atoms. For example, water. So it has 3 atoms. So we can also use it this way to describe its structure. So in this case, we can say the oxygen and hydrogen they share 2 electrons. For these 2 electrons, one is from oxygen, the last one is from hydrogen. So using this way, we can say the oxygen now has A electrons. At first, it has 6 electrons, and then it gets 1 from this hydrogen, and also share 1 from this hydrogen. So now it has A electrons. So it is stable. So in this case, we can say for these 2 electrons, we can use a short line. We can use a short line. So here we can say there are 2 single covalent bonds. Besides these 2 single covalent bonds, the oxygen still has 2 null pairs. 2 null pairs electrons. Okay, so in this case, it only has single covalent bond. Now, here is to show the formation of double covalent bond. Okay, so have a short break.